So here they say to us, a person with a mass of 60 kilograms climbs to the top of a mountain, which is 6,000 meters above the surface of the earth, ground level. All right. Then they ask you to please state Newton's law of universal gravitation in words. Well, I trust you to take care of that one. Then next they say, calculate the difference in the weight of the climber at the top of the mountain as well as at ground level. And of course, you understand that the weight difference in mathematics means something minus something else. It means you need to calculate the weight when this person is on the ground level. Calculate the weight again when he's now 6,000 meters above the ground, and then find the difference of those two weights. That's all you need to do, and you should be fine. Well, so now we need to specify and say, when he's on the ground, then this is what is going to happen. Okay? What is going to happen when he's on the ground? Well, nothing much except this. So you'll state your law of gravitation and say, well, the gravitational force will be equal to Gm1, m2 divided by r squared. And now you come and say, well, this is what we are having. And then you say m1 is the mass of the earth because he's on the surface of the earth. And then m2 is the mass of this person. And they said to us it is 60 kg, right? Of course they did. Yes. So we multiply this by 60. So this is what we have. And then we say this entire thing is divided by the radius of the earth because he's on the ground. Okay. And this is what we have. And we square this. So now we can come and say we have 6.67 times 10 to the negative 11. This is multiplied by 5.98 times 10 to the power 24. And this is multiplied by 60. Then you say, well, this is divided by 6.38 to the power 6. And this is all squared. And when he's on the surface of the earth, his weight is 587.95 kilograms. Okay. Now we need to come and find his weight again. But when he's now on the mountain, right? Right. So this is what is going to happen when he's on the mountain. You can still state the law itself, or you can substitute directly. It's allowed, okay? Because this is one question. You don't need to write the same formula twice. Then once again, he's still in the Earth's gravitational field. So it means the Earth is still exerting a force on him. And then we say his mass is still the same, of course. But the difference is he's now at a certain height above the surface of the Earth. So we are still going to take the radius of the Earth, but then we have to add it to his height above the surface of the Earth. Or we can just say above ground level. Let's say that to make things easy. And if you press this into your calculator, you simply get 586.84 Why am I saying the force is measured in kilograms? Hey, guys. Guys, why are you silent? Right, the force is measured in newtons. Please don't be like me in the exam. I'm really sorry for that. I think you're rather confused, innit? Yeah, I'm really, really sorry. And then from this point, we can come and say, therefore, well, the difference is the bigger one, of course, minus the smaller one. You're not going to say final minus initial here because final is less than initial. And so your weight will be negative. That's not the point. We just want to know what is the difference in the weight. Okay. Weight cannot be negative. It's a scalar quantity. Imagine saying I weigh negative 54 kilograms. What are you saying? So it can never be negative. So if you press this into the calculator, you simply get 1.11 newtons. I nearly repeated that thing of saying kilograms again. So, yes, that is what you are supposed to do. Find the gravitational force on the surface, find the gravitational force at a certain height, and then find the difference between these two gravitational forces. And you should be happy.